Hey everyone, today I'm going to be explaining the concept of binary search algorithm, what it is, where it's used, and its implementation in Python. Basically, a binary search algorithm is a searching algorithm which is very efficient when we compare to our traditional linear search algorithms, and it is extremely useful when searching through large amounts of data. And as you can see, a sorted list is extremely crucial towards its implementation. So let's see how it is used, shall we? Now, before we begin, obviously we'll have to do some required preliminary stuff which should be completed, such as, say, taking the inputs for our array, or you can call it a list, doesn't make a difference. So we'll say array eval of input, and then with the key variable, we are denoting the element which we wish to search for in our array. And then thirdly, by n, we denote the length of our array which we are taking over there. And then finally, one of the more crucial steps would be saying array dot sort. By this, we are actually using the Python built-in function to sort our array. And this is a very, very important step towards the implementation of binary search in Python. Now, a few of the other stuff would be let me just finish it. These are all conditions to check whether the element is present in the array or not. Or else we would say print out element from index, and we would supposedly return the index at which we found our element. Okay, now since all the pre-processing is done, now we'll actually start assembling our binary search function. And it is most recommended to always implement this inside a function, since if we do not do that, we would not be able to say whether the element is not found much more efficiently. So now we begin def binary search of array comma key comma n. Basically, it's taking three inputs: the array, the value to be found, and the length of our given array or list. Now, once inside the binary search, we will designate two variables. One is left, which is value will be initialized with 0, and the other will be right, whose value will be initialized with n minus 1, or the last index of the last element in the array. We are doing this so as to set two pointers, one at the start of the list and the other at the end of the list. Like, take for example, in this image, we are taking this array which consists of these elements 2, 4, 6, 8, 10, 12, and 14, and our supposed key or the element to be found is 10. Now we are setting two pointers. Left should be at the start, which is the first element of the array, and right, which should be at the end, which is the last element of the array. And after this step, we will designate a breaking point, or a condition with which we will end our looping once the variable has been found, or if it does not exist in the array. And that condition should be while left is less than or equals to right. By this means, what we're saying is that during a binary search, at any given point in time, we are only searching half of our given array. So if a pointer exceeds its given half, then we would terminate our condition saying that the given element is not present in the array. Now, as you can see here, next, while inside this while loop, we will designate another variable called mid, which value would be equal to the value of our left plus the value of our right, floor division by 2. This will basically give us the index of the middlemost element in the array. Now, by using this, we will put forth our first checking condition: if key is equals to array of mid. Now, by doing this, we are checking if the element that we are supposed to check for is present at the middle of our given array. If it is present so, then you would say return mid. Else, there is the other condition is that the value at the mid is less than the value of our key. Then that would mean that left is equals to mid plus 1. That would mean that the element we are searching for is greater than the value at the middle. So that would mean all the values before the middle would also be less than our key value. So we do not have to search for half of our list. This way the binary search algorithm computes the searching time to exactly half over here. And we are setting our leftmost pointer to a point that is after the mid. So for example, we are searching the middlemost element is 8 here, and we have computed 8, but 8 is not the key that we are supposed to find. So what we will do is that we will move our left pointer, which is at 2, all the way to 10. So this would mean that we will not have to go through the elements 2, 4 and 6. So now the array will be changed to 10, 12 and 14. But the other condition also is that else if the element suppose were to be 4, then the value of 8 would be too large. So that would mean we'll have to move our right pointer from 14 all the way to 6. Thus we won't have to search the elements 12 and 10. So this way we can cut down the array by half depending on the value that is present at the middle. So here we would say right is equals to mid minus 1. And now the final condition which we spoke about before, if the condition left is less than or equals to right ends up becoming false, then we would return -1, meaning that the element was not even present in the array to begin with. So now let's run this program. So first it's asking us for the inputs which we are required to give to it. So let's just say those would be 2, 4, 6, 8, 10, 12 and 14. Now it's asking us for the key with which we will have to find in the array. So let's give 10, enter. So now basically what it's giving us is first it's printing out the array, and it is printing out the element at which it was found. So it is saying the element was found at index 4. Now once we check over here, it would be 2 is at 0, 4 is at 1, 6 is at 2, 8 is at 3 and 10 is at 4. So that clearly means our binary search algorithm has computed the search time to find our key within the given array. Now let's say we run it for an element that is not present in the array. How would that go? So let's say we once again we give the same list. And guys, keep in mind that if you're using eval of input, it is pretty necessary for you to mention the square brackets when giving the input for the array. So now, and let's give a number that's not present, so we give 1. So it's printing the array and it's giving us element not found. So this is how a binary search algorithm functions in Python. It finds a middle value, computes to check if the middle value is the key value in the array, and finds out if the middle value is less than the given key value, thereby shifting to only one half of the list, or if it is greater than the middle value, therefore shifting to the right half of the list, or if the value is not present in the list at all. This is Priyadarshan. Thank you very much for listening.